So I find this section one of the more exciting sections in this class in Math 10 because it lets us find zeros of higher degree polynomials. Quadratic equations, we've done that, we've solved those before, but now we're doing like a cubic equation or something even higher, and we can find all the zeros with using these principles. Okay. And they are select polynomials. Okay, so here we go. Here's the process. It says find all the zeros of, and it gives us this function, right? So we're saying, when does that function equal 0? I mean, that's what we're trying to find, right? Okay, we know from the factor theorem that if we divide synthetically by a number and the remainder is 0, then it's a 0 of the polynomial. Okay, so what are the possible rational zeros here? Well, P, those are going to be factors of 6. It doesn't matter that it's a negative 6. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then you look at the leading coefficient, Q, and will be factors of 1, plus or minus 1. Now, that's great. When the leading coefficient's 1, then there aren't any fractions, so that helps a little bit. But anyway, because you're putting these all over 1, you know, this is just going to be the possibles. So there are 8 possible zeros, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are the rational, possible, rational. They're just the rational choices, possible rational zeros. That's what the rational zeros theorem says. Possible rational zeros. It doesn't say those are the zeros. It just says those are the choices. If you're going to have a rational zero, it's got to be one of those 4. Now, how do you know which number to try? You can just pick. I always do 1 first. 9 times out of 10, 1 works. I shouldn't say that. Probably not that often, but a lot of times 1 will work. Okay, what am I going to do to see if it's a 0? Well, I'm going to use synthetic division because that'll go faster. So I pull out those coefficients, 1, 2, -5, -6. If the remainder is 0, then 1 is a 0. If it's not, well, then I'm going to try a different number. Okay, so bring down the 1. 1 times 1 is 1. 1 and 2 is 3. 3 times 1 is 3. -5 times 3 is -2. -2 times 1 is -2. Okay, it didn't work. So it didn't come out to be 0, so I know it's not 1. Let me try -1. Let's see. Now, at this point, you might be saying, well, what if -1 doesn't work? Well, then I'm going to try 2 and then -2 and so on and so forth. So I have to try it at most 8 times, but we'll see what happens. 1, -1, 1. We're doing synthetic division. 1 times -1 is -1. Ooh, I have a good feeling about this. -5 and -1 is -6, but -6 times -1 is 6. Okay. All right, so we found one. Yay, happy face, star, whatever you want to say. -1 is a 0. Okay, so you know one of them, but it's even better than that because now that you know 1, you know the division. You know that x plus 1 is a factor, and the other factor comes from right here. It's going to be x squared plus x minus 6. Okay, now, you don't have to write this, but I wanted you to have a visual of what's actually going on. We found a 0. That means we know a factor, and it means we know the other factor. And this is quadratic. And the great thing about being a quadratic is if we have to, we can use a quadratic formula. But we don't have to this time. Okay, so go ahead and take that polynomial, x squared plus x minus 6. When does that equal 0? It's quadratic. It factors. Even better, it factors. X plus 3 times x minus 2. Okay, so you could check that, but 2 numbers that multiply to be -6 and add to be 1, and those are 3 and -2. So that's, you do the factoring. Okay. Anyway, set each factor to 0. So when does x plus 3 equal 0? That's at -3. When does x minus 2 equal 0? That's at 2. Okay, so we know 3 zeros. Now, does it say find all the zeros? I think it did. Yeah. Okay, so usually if it says find all the zeros, we're going to say the zeros are, you could put it in set notation, but the zeros are negative, and I don't care what order they're in. They usually go smallest to largest, so -3, -1, and 2. Now, where did the -1 come from? Remember, we found that one, and that one was important because then we had a quadratic we could work with, and then we found the other two. Okay, so those are the zeros, -3, -1, and 2, and that's the process. So, fun stuff.